Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan from the Simple Electronics YouTube channel. And with me, I have today a very special guest. I have Moritz from the Enwi YouTube channel. Did I pronounce that correct?
Yeah, Envy, it's fine. Hello
Oh,
from
yeah,
me too.
Envi. I forgot
Envy.
German with the V for the W. I completely
Yes,
forgot.
it sounds like the English word with a V or yeah in it.
Yeah, envy. Yeah, I always get that confused when I talk about the screwdrivers. We call them Wera, but it's actually Vera because it's a German company, if I'm not mistaken.
Yes, Vera.
There we go. And you guys also say Knipex correctly, which I don't.
Night packs.
Yeah, isn't it Knipex with a hard K?
Knipex. Yes.
Yeah, there we go. Oh, sounds like I'm talking to Great Scott right now.
Yeah, it will probably be very similar.
So we've chatted a little bit before this podcast, but I don't know you all that well. So can you introduce yourself to me and the audience? Let us know a little bit about yourself before we get started.
Yeah, it's fine. My name is Moritz. I'm from Germany, obviously, if you haven't heard the accent yet. And I'm 25 years old. I have studied computer science and I'm working at the German Aerospace Center in the sector of solar power. That rounds it up.
No way. You've got a professional job working in solar panel for German Aerospace Center.
It's not solar panels, it's concentrating solar power, but yeah.
Oh, so okay. Let me take a stab at it, and you can tell me if I'm way off. So concentrating solar panel power, meaning like reflecting solar power onto, let's say, like a chamber to heat up water, for example.
Yeah, there are pretty different scenarios there, but it's pretty much a lot of mirrors, which are then controlled by a software and then concentrated onto a target or aim point, which is a receiver of some sort, which can be an air receiver or molten salt, for example, or even particles like bauxite. Don't know if I pronounced that correctly, but yeah.
That's really interesting. So what's the goal here? The goal is to use the heat to generate electricity?
Mainly, but you can also use it as process heat for example, drying noodles or you name it.
Drying noodles. We're trying to make 5-cent ramen noodles by using $10,000 solar array.
Yeah, I think I can talk about this project because it's a European project with Barilla. I think you know that company.
Yeah, it's literally a noodle company. I thought you were
Yes.
joking.
No, it's not a joke. We are working on this project with Barilla in Foggia in Italy. And there they are planning to build a concentrating solar power receiver, I think with particles. And they will use the heat to produce energy and also cook and dry noodles.
That's actually awesome because I guess solar panels are sort of indirect energy because you still have to convert it from the solar energy to electrical energy. But I guess this kind of solar energy could be used direct. You literally are using heat to
Yes.
heat up something. So that's I'm assuming there are fewer efficiency losses when you're using, similar mediums.
I'm only developing the software which controls the mirrors, so I'm not a lot into the inner workings of all the receiver and the losses and such. But yes, I think the efficiency is a lot higher than using solar panels.
That's awesome. And so I guess you went to school for computer science. That means you did a lot of, so you learned programming in
Yes.
in university.
Yeah, that's correct.
So you are an actual wizard. That's what I
wizard.
say. Yes. Yeah. Honestly, I think coders are wizards because the amount of stuff that comes out of coding, which is these days everything, is mind-boggling. And coming from a guy who's on chapter 5 of the Teach Yourself C++ textbook, Trust me, coders are wizards.
C++ is only the beginning.
I know. Don't even start. I'm already depressed.
But I guess in terms of software, C++, in my opinion, is a good starting point because it's like being thrown in the cold water. And I think it's the best way to learn software by starting with C++, which is kind of hard at the beginning because getting to know or trying to figure out how pointers and such work and the memory and stuff and allocations or references is pretty hard, but it's also one of the basics you need to know for other programming languages which hide these things, like Python, for example. You don't have to deal a lot with pointers or something like that in Python.
I'm not at the point where I know what a pointer is, but I do. Like we're heading into functions right now, which is it's been a point of contention for me for some reason. Programming and we don't see eye to eye. It takes me a lot more brain power than I feel like it should. But I chose C++ because I do a lot of work with Arduinos, and so Arduino C is sort of C++, kind of, sort of, maybe.
It uses the normal C++ compiler, and I think currently even the C++ 17 standard. But don't take my word on it.
Yeah, I have no idea. Like I'm again, I just I scraped the surface, but my goal is to eventually become a competent programmer that can make software that someone like yourself could open up and be like, okay, I understand what they did here, instead of like open up, be like, what happened here? Like looking at a car crash or something.
That's often what happens when I look at some other GitHub repositories, and that's also kind of the reason why a friend of mine and I developed our Hue++ library, because that's a long story, but
Go ahead. This is the podcast. This is a long form content here.
So we started out, I don't know, the year, it was 2015, 2014. And I came up with the idea of making our own smart home system. And I saw this event at school from, I think, even RWE, the German company, electricity company, which also do a lot of other stuff. And they had this thing where you could win a prize with a project from your school. And so I took place in that, I'm missing the word.
In the program?
Yeah, in the program. So I found, because I couldn't do it alone, my teacher recommended someone else to join our team. So I managed to get a team together from our school, and the guy, his name is Jan. He's a few years younger than me, but he's a lot better and a very smart guy in programming. So that's why he's also not studying computer science, but that's a different story. So we went to this event, and we didn't win, but we got under the top 10. But basically, we developed a smart home system based on C++, which is also on GitHub, if anyone is interested. We are not working on that project anymore because we just gave up, because, for example, Home Assistant or OpenHub are so much better than what we managed to build. But we learned a lot of it, or from it. And one thing that we wanted to do with the smart home system was to control Philips Hue lights. So we went online and looked through GitHub and searched for a library that we could use. But none of them really appealed to us. I mean, there were a few libraries, but they didn't fit in our programming style, nor did we like how they were implemented. So while we were working on this huge task of a smart home system, we started working on creating our own C++ library for Hue++, or named Hue++ for Philips Hue lights. And I think we currently we implemented all the features from Philips, so it's a full-blown library where you can do everything, even the casting stuff with Philips Hue, and that's something that arose out of the old project of the smart home system. And there are a few people who actually use this library. There's this program called OpenRGB, which you can use to control all the lights on your PC, like monitors, graphics cards, and keyboards. And the guy from OpenRGB liked our library so much that he used it in his program, which is also open source, to add support for Philips Hue lights.
That's really awesome. So, but the Philips Hue that it takes a like, doesn't it communicate over 2.4 gigahertz, like over the network?
Yeah, the Philips Hue lights use Zigbee, if
They use
I'm correct.
Zigbee.
Yes, so you have the Zigbee network, but they also have a bridge, which is a gateway in that regard. And we implemented the reference or the API to connect to the bridge to control lights.
So you just need something to send the signal in Zigbee's format, but your software is kind of like it's like a translation.
No,
layer.
It's not translating, but it connects. So Philips Hue made some API functions, or it's a REST API. So you do a get, put, or post, or delete request, something like that, and you send that to the Philips Hue bridge, and you say turn on light 1, and then the Philips Hue bridge will send a Zigbee command to that light.
Okay. Thanks for being patient, because again, me with software, not very good.
No worries.
But since it is written in C++, and since I did read, chapter 1 of my textbook, that means that it's very light, isn't it? That means you could run it on like a small microcontroller, for example.
Yes. The library itself, I haven't tested it by myself, but I guess you could use it on the ESP or even Arduino to control these lights. We did test it on Linux, macOS, and Windows, which works fine. But I think someone tested it and used it on an ESP, I guess, which should work. But I haven't tested it by myself yet.
So for those that are listening that don't quite understand, the way I understand it, and you can correct me if I'm wrong, but the way I understand it is when you're coding in C++, it's just that's only for your benefit. When you make a binary, or when you sort of compile it, you're compiling it for the specific device or operating system you're going to be using, and so the code you write doesn't change, but the output code will be different depending on where it's going to be executed, right?
The bytecode, yes. The bytecode will be different for each platform.
See, just getting to that point was a lot of work for me. This is what I'm telling you. Coding and I don't get along.
It's even hard for me to understand all this compatibility, because once you get into shared libraries or static libraries, it gets a lot more complex than that. Shared libraries meaning that you have some sort of library like Philips Hue or the Hue++ stuff we made, and you compile that into library functions which get installed onto your device. So it's like it's a file that gets stored on your device, and it was compiled for that device. And then you can write another program which doesn't need to know the implementation of anything of the code, but just the definition. And then it can, once your program runs, it can load the shared library file, which it finds on the PC, on the file system, and then use it to control the lights without needing to include the binary or bytecode into your own program, for example.
See? Wizardry.
But that's only the tip of the iceberg, and I'm probably not the one who can explain it very well, but
I do have, you know what? I do have a lot more software devs who want to come onto the podcast. So I will be exploding my brain in the same way on each and every one of them, because you folks are honestly wizards. I can't believe it.
Maybe you can learn something.
Maybe, but I don't know. I wouldn't bet money on it. It's tough. I wouldn't be able to do it at the university pace, learning, 5 classes per semester worth of stuff.
I studied it, but it's only still. I didn't even during my study. We didn't even talk about C++. It was all Java. So most of the classes just use Java because it's a lot simpler to explain and for students to learn than C++.
But in your first year, you guys were more talking probably about how computers specifically work, like how.
That was not the first year.
No, really?
No. The first year was actually where we had the programming class with Java, and then the second year we had computer architectures.
Interesting. Huh. Well, there you go. Maybe I'm learning it backwards. Or no, but the correct direction.
I don't know which is the correct direction. Maybe it had to do with the teachers or something like that.
Who knows? But you have been designing, I don't know if they're open source, but at least they're clones of the Nanoleaf. Can you explain a little bit what that is and maybe walk us through your project?
Yes, so the Triangulum Project, which we call it, which is just the Latin word for a triangle. We just needed to find a good sounding name, and that was the easiest option, I guess. Just use another language to use a simple word. I think many companies or projects do and use that.
Oh, definitely.
And the Triangulum Project was also an idea of me. So I really like the Nanoleafs. And I've seen many Instructables and also other people trying to mimic them. For example, just they will print, for example, a shape they like, a hexagon or a triangle, and then put in an LED strip and call it a day. But I guess that wasn't enough for me. So I first started with doing mostly like an exact copy of that. So the Nanoleafs, the first ones are like these triangles which you can put up on a wall, which light up, and you can control the lighting patterns and effects and colors and such. And you can connect them however you like. So they snap together. You can put them up on the wall. But I really didn't like the price of them, and that the first Nanoleafs only allowed for a maximum of 30 triangles at a 30 FPS refresh rate, and you could only have a single color per triangle. So I wanted to have something better than that. So my idea was to also do triangles. I know they've come up with other shapes now. I think they started with triangles, then they made squares, and now they made their new shapes, which are triangles, small triangles, and hexagons, I guess.
Well, we all know that hexagons are the bestagons.
Yes, so hexagons are the bestagons. If you watch the video. So I wanted to do triangles because it also makes the bestagon, the hexagon.
True.
And I think compared to squares, you can get a lot more interesting shapes out of it by hooking them up together. So, where did I start? So the first thing I tried was just get an 80 tiny microcontroller on each triangle and have some serial communication bus going through all triangles, and then have some sort of intelligent algorithm which can figure out how the triangles are interconnected with each other. So the idea here was, and I probably copied that from another project that I saw online, where someone was using not ATtinies, but I think PIX microcontrollers, PIX Hawks, for
Probably.
that. And the way it functioned was that each triangle was made out of 3 individual PCBs, which got soldered together. And then on one PCB there was a microcontroller and some electronics to because they were using those 5-volt LEDs.
Yeah, the WS28112Bs.
Yes, those are the 12-volt ones, the 5-volt ones. Sorry. So they were using 12 volts to power everything, and then they had buck converters on each triangle to get 5 volts out of it. And they also had some kind of logic that they would connect a digital pin to each side of the triangle, and then had a software and a serial communication protocol which would communicate with the first triangle, which in turn then would pull down one of each of the 3 sides. So in order to communicate with the first triangle, you would have to pull down one pin of one of its sides. So that's where the controller lives. So the controller pulls down one side, so the triangle is allowed to answer. So that's the protocol to figure out how the triangles interconnect with each other, so you don't have to do it before you put up the shape, so you can do it on the fly. So what they were doing was pull down one side so the triangle can answer. Then the microcontroller would initiate this triangle with an ID, and then pull down one of the other 2 sides. That would then in turn make it possible to communicate with another triangle connected to it. And then this algorithm would go through the same procedure on every side and on every triangle it found to then figure out what the shape is. And then you know the shape. It's pretty complicated, I guess.
It does sound very complicated. And this is the way that the original ones do it, or the way you do it?
No, that's the way someone did it and the way we tried to do it. So we exchanged the PIC microcontroller with an ATtiny to make it simpler, and I think a lot more people use ATtinies. And then we tried to test the stuff. So we got a few PCBs. And the first issue we then discovered was that just hooking up a bus on all sides just introduces so much noise, because on every connection you get a reflection of the signal. I don't know if I'm going too much into detail, but
No, that's fine. So we'll just simplify it for the people listening. But basically, if you send a signal down a trace that's a dead end, then it basically bounces back up the line.
But not only for dead ends, but also for medium changes, I guess. So if you have a trace on a PCB and then go to a through-hole component, for example, a pin header, and then to another pin header, those are also the contact points of those where the material itself, the trace is a different material than the pin header, for example. So this is also a place where you will get reflections of the signal. It's a lot smaller than dead ends, but they are still there and they are still measurable. So the first test we did was just with one triangle, which worked flawlessly and fine. And another thing we wanted to do is, since the first nanOleafs only worked at 30 FPS, we wanted to get out of it 60 FPS, for example. So the bus we were using, the serial connection, needed to be as fast as possible, like, for example, in the range of 2 megabits per second, which is very fast. I think most commonly used serial speed is 9600 baud, so 9.6K. And 2 megabit per second is a lot faster than...
Let me explain it this way. A lot of people in North America still cannot get internet faster than, in the 2 megabit range. Like, basically rural areas, forget it.
Yeah. So what we wanted to do is get more than 30 FPS, and also we wanted, since the nanoliths only could control the whole triangle as a singular color, we wanted to have 6 LEDs on each triangle, so one in each corner and one in the middle of each side, so to illuminate it better. But we also wanted to be able to control each individual LED. So we thought of a protocol to set all the LEDs, because you need to set one value for each LED. So for red, green, and blue, it's one value. So 3 bytes per LED. And then you have 6 LEDs on each triangle. So 18 bytes per triangle you need to send, essentially, plus some other data for the triangle to know which triangle you are talking to. So you have
the scope is like accelerating here. Like it's becoming more and more complex as you keep going.
Yes. So
Wizardry. I'm telling you, you're a wizard.
there are just a lot of issues. So one issue was that the speed needed to be extremely fast to get more than 30 FPS and to be able to control each individual LED. And also, speeding up the communication introduces more and more noise. And a higher baud rate has more reflections or larger reflections. So we had this issue, and then we thought maybe we should use a different microcontroller, because for the ATtiny, we would use a custom external oscillator to get the microcontroller faster, for it to be able to do the 2 megabits per second baud rate. We could get it reliable up to 1 megabit, but 2 megabit was just out of reach. So what we did is we exchanged the ATtiny for a nucleus from, what's the company again?
I'm not sure.
The other microcontrollers, the bigger ones.
ST?
The ARM, yeah, STM32.
Okay.
So we exchanged it for an STM32 because it's a lot faster and a lot more reliable, also on detecting the serial communication. So we then went through the whole designing process, new PCBs, new software, because also different software, a lot more microcontroller dependent code needed to be written to be faster, and also because of the nature of the STM32, because you don't have all the nice Arduino functions and such on there. So you have to control registers directly and set up every single bit in all the control registers correctly for it to work.
So are you literally diving down in the data sheet and then basically writing code like that, basically?
Yes, yeah.
What a pain.
Which sucks, yes. But you get a lot of speed in turn, because, for example, if you do it on an ATtiny and, for example, you want to control 5 GPIOs at the same time, you can write the value for 5 GPIOs into the register and have it done in one clock cycle, instead of using the, for example, digital write method of Arduino, which uses several clock cycles per pin you want to set.
Yeah. I've been meaning to time it. I have the equipment here to time it. I've been meaning to go and check the speed difference between doing a digital write on a Arduino, and by just doing the hard code for it, and then comparing that with an ESP, which has something like triple the clock speed or whatever.
Yes.
And seeing the difference there too, because to me that stuff is interesting.
Yeah, it is, and you can get a lot more speed out of the ESP if you do it right.
Yeah, probably, but it's going to be on my channel, so no guarantees on being done right.
If you do it wrong, it could be worse than using an Arduino or an ATtiny.
Well, at least it's going to be interesting.
But I think in most of the libraries for the ESP, for a quick detour, there are some ways where you need to put intentional delay in the code because it's too fast for some hardware or protocols to work correctly. So sometimes you have
Yeah,
to do a microsecond of delay or something for
that makes sense.
it to be right. But yeah, so back to the project. So we then got an STM, got new PCBs and such, and then tried everything with the STM, but still, yeah, surprise, surprise, same issues as before with the bus and the reflections on the bus. So we couldn't get a clear signal. It worked a little bit better than the 80 tinies, but we also had to then introduce some code which would manage to correctly interpret frames for each triangle. And that was just a pain. So I then went ahead and just sat down and thought, maybe we should screw all the microcontroller stuff. Because what the microcontroller essentially is doing is taking a data packet of which we designed ourselves, what the data means, and then translate it into the data which gets sent out to the LEDs,
Yeah, because
which is
for
also
those
the bus
listening,
system.
the LEDs have their own microcontroller inside.
Yeah.
They're looking for a specific chain of, basically, it's like a bit chain that you send out. You can, in fact, if you were good enough, you could just send it you could bit bang it. You can basically send high lows in order on certain timing, and they'll work because they have their own micros inside.
If you have a fast hand, you could probably do it like Morse code.
Yeah, you have to be pretty fast, but yes.
I think there is a lot of tolerance for these LEDs, but yeah, you would have to be pretty fast. But yeah, so I thought the LEDs also already have their own protocol, which has been tested for years and years because these LEDs are like around for several years now, and the guys who made this hardware must have thought about something like the issues we had with like signal integrity and what data you need to send. Less data gives you more LEDs you can control in the same time. And yeah, so I thought, let's just throw out the microcontroller and just make PCBs with LEDs on it, and then we will just interconnect them on the sides of the triangles, and then just use the nanoleaf, not the nanoleaf, the nanopixel or the neopixel protocol for that, which is fast and more reliable than what we did because the signal gets amplified by each LED. So you get a very clean signal. And since we were using the WS20, the WS25, I guess. Or,
The 12-volt version?
yes.
That's I think it's the 2813, but I could be wrong.
2815.
15. Okay.
2815. So that's also the 12-volt version. So before the design, we had to have also a linear dropout regulator or some sort of buck converter to get the 3.3 volts for the microcontroller. So screwing the microcontroller just simplified things a lot. So you have a lot smaller bill of materials because you literally have 6 LEDs and 3 PCBs per triangle. And before we had to do 3 individual PCBs because the traces on each PCB had to be different. And now we could just make one PCB and just use the same PCB for all sides of the triangle. So we not only reduced the bill of materials, we not only solved all our communication problems, but we also made the whole design a lot more easier, and you could manufacture it in a bigger. So for the old design, you would have to get 3 different PCB designs made, and now you would only have to get one PCB design made, which you could also panelize, and then with SMD soldering, get a whole panel done pretty quickly. So that's what we did. We got a prototype of those, and we then figured out another issue, which is a mathematic problem, because now since we have data going in on each side of the triangle and going out on each side, because we need to interconnect these. So we need to have a bus which goes through all triangles to be able to control all LEDs. So what we had in mind was to have jumpers for the open edges where no triangle is connected, which just jumps over the signal to the next side from where it could go to the next triangle. I think it's hard to explain how that all works out, but the issue with this concept was that there's this mathematical problem where you want to tile a space with a geometry, for example, the triangle, which fills the space nicely. So there are no holes in there.
Yeah, no gaps.
Yeah, no gaps. So that's easy. But then there's another mathematical problem where you want to have, for example, a thread which goes through all of the shapes you tiled without leaving gaps. So the
And
thread,
without crossing too, right?
yeah, no crossing, no gaps. Turns out triangles are one of the shapes where this problem can't be solved.
Oh no.
So you either have gaps or you have crossing signals. So what we had to do was stick with the jumper solution. And to make it a little bit easier, we included a switch. So we put a switch on into our design, which could just jump the signals by flipping it. So that makes it a lot more simple. But now the easy thing is now with this design, we can just have parallel signals going to each triangle with data and power, and just have a PCB with socket strips on each side, which just connects two triangles to each other. And then on the triangles, in some cases, you have to flick the switch, and in some you don't. So what my friend did, Jan, again, he made a visualizer software where we could put all the shapes together however we would like. And the software would also include an algorithm which he designed, because now we need to know where we need to flick the switches, because otherwise we would get the holes, right? Because that's the problem, the mathematical problem I was talking about. So I thought of an algorithm to solve this issue. So the software could tell you where you need to flick the switches for it to be able to control all LEDs. And my first attempt failed, but Jan then sat down for a weekend or something and then came up with an algorithm which would, for all shapes thrown at it, figure out the correct switches to be flicked, which is not a simple algorithm. I myself haven't looked at it yet. But
this is incredibly complex, and I'm really glad you're talking about it here on the podcast, because it's really important for people to understand, especially non-makers, because I think makers kind of all understand this collectively, but for non-makers, something as simple as putting stuff up on the walls that are interconnectable and light up is not as simple as you may think, because as you've noticed, it becomes very complicated very quick.
Yes.
And just adding one little string to it, oh yeah, we want to be able to address the LEDs individually. Well, that causes chaos, because if it was just dumb RGB LEDs, you could just send one ground and then 3 power lines, and you just parallel them everywhere.
Yeah.
There would be zero issues. But now, because you need to send them down one path, and you actually have to number them, 1 through whatever 255, because if they don't get the data in order, you'll have like one leaf at one end getting the color it's supposed to be at the other end. It became really complicated. So I'm really glad that you're going through this with us on the podcast here.
Yeah, it's there's a lot more I can talk about, but there are so many issues with this. We found so many issues on the way. So this project is going on for over a year now, and we are still not really done. I actually have finished soldering all 150 triangles I wanted to solder, which are 900 LEDs. But I will talk about that a little bit later. But so once we figured all of that out, the program now knows where the string of lights or how the string of lights is connected to each other, because each triangle is the same connection wise. It doesn't matter how you rotate it. So you pretty much have only two ways you can rotate it, with the pointy side up and with the pointy side down. And what Jan did was make a software which could store all this information and how each LED is positioned inside a matrix, for example. So we can not only individually control each LED, but we can also take a picture, for example, and display it correctly on all of the LEDs by interpolating the pixel position of the LED to the source image you want to display. Or we also implemented some effects which get rendered onto the LEDs. So what the visualizer does, what he made, is you can just click. It sounds so easy once you have all this interface and such. You can click together all the triangles however you like them, and then you can just press a button, so it generates where you need to flick the switches, and it also generates the path of the signal. So you need to input the signal at a specific position in order for it to do it correctly. But the software not only runs on the PC or a Mac, because the visualizer can run on a PC, but it can also run without the visualization stuff on an ESP32, for example. So our controller in this project is an ESP32, which controls all the LEDs with direct memory access, which is also another topic on itself. But yeah, so this whole software is also a pretty big part, because you need, in order to display a simple effect, like not only with effect I mean not all LEDs set to the same color, but for example you want to make a wave, or you want to make you want
them
to make
to twinkle, or do you want them to
whatever.
Yeah.
You need to know where all LEDs are, and you need to know how you can project your effect onto those LEDs. So that software part, that's all what Jan did. And it's pretty huge. But he understands software and software development far better than I do. And he's the superior software developer. And I cannot thank him enough for being part of this project, because otherwise it wouldn't have turned out this way. But essentially, we made a control software for the PC where you can visualize everything, so you can render it. He actually wrote a shader for the program, so it would render with light attenuation and diffusion, like in the real world. So it looks pretty much the same as the real thing.
So, but like, you don't have a video showing off this this stuff working, do you?
There is some stuff on Instagram.
Oh, I see.
And on my Discord server. But yeah, I'm working on the video for YouTube, but I hope to get it out this year. But it's a lot of work. I still need to solder the interconnections and such. But pretty much, we also wrote an app for Android using Flutter, so the app can also run on other platforms, for example, iOS or even a PC. And we wrote an app where you can control the ESP32, and you can also display all effects that we made directly from within the app on the ESP. So the actual effect gets rendered on the ESP and then spewed out on the serial bus for the LEDs. And we can render at 60 FPS on the ESP.
So, but at the end, though, you're actually going to have I hazard to say better, but it sounds like you're going to have a better product than the Nano Leaf because you'll be rendering faster, or sorry, updating faster, and you'll be able to individually
Yes, we have
address the LEDs.
6 times the LEDs to render, and we have double the update time. And I think it should work with 150 triangles with one controller. So comparing to the first Nanoleaf version, which could only do 30 triangles max, we pretty much destroyed that limitation by like supporting more than 150 triangles, which are 900 LEDs. We also broke the 30 FPS limit, having 60 FPS. And yes, as I said, we can have a single color per. We don't only have a single color per triangle, but per LED. And we also made a lot more features than that. We also integrated a way where you can input a screen capture onto the LEDs. So when you use the visualizer software on your PC, it can connect either through serial communication to the ESP. So you can connect the ESP via USB to your PC, and then it opens the serial port and can control the ESP with that. But we also implemented a TCP and UDP communication. So you can just connect the ESP to your Wi-Fi and then have the control software on a PC and then send data wirelessly to the ESP and display it onto the triangles.
So do you have a master triangle with the ESP in it, or is the ESP separate?
It's separate.
Okay.
So there's no master triangle in that regard. And yeah, we can also do a screen capture. So if you have, for example, a video you want to display, you can live stream it to the ESP with the visualizer software on your PC.
Yeah, this is crazy. So what if the Nanoleaf company messages you and says, "Hey, we want to buy your project"?
I don't think so.
No? It's going to be a no. There's no amount of money.
I don't think so that they will do that, because the newer version, the Nanoleaf shapes, I think they also broke the 30 FPS record and the maximum of 30 triangles. I think you can connect more than 150 triangles or hexagons or mini triangles with that new version.
Okay, but can you put a screenshot on it?
I don't think so.
Exactly.
But
this is what I'm saying.
Fun
what
story.
about €1 million?
Fun story is, while we were developing this project, Nanoleaf came out with the new version of theirs.
Yeah, that makes sense.
So I was like, now I need to beat the new standard. But no.
So is this open source, your project?
Currently, we don't have published any of the source code or anything, but we are going to open source everything once it's ready.
Yeah, until Nanoleaf says no, we're buying it.
Yeah, I really don't think so that they will buy anything of that. It's more like it's like very user unfriendly, because with the Nanoleaf stuff, it has one feature that we don't have, because for the Nanoleafs you can press on a Nanoleaf and you can interact with, for example, the Nanoleafs by pressing on it. So it can either trigger a home automation thing, or you can play a game on the Nanoleafs. We can't do that because we don't have the serial communication with microcontrollers. If we would have solved all the issues, we could have integrated a button or something and do the same. But that's also one thing the Nanoleafs can that we can't. And also, as I said, you have to flick all the switches on the thing. So you need to figure out your shape, put it up on the wall, then put it into the program, and then flick all the switches how the program tells you. And for the Nanoleaf, you just hook it all up together and it just knows how it's connected.
Yeah. It gets very complicated, but hey, I mean, maybe they do want to buy it. Who knows?
Yeah, so more facts of the project so far. As I said, 150 triangles. I have soldered all of them now, which are 900 LEDs. And by hand, I had to do 4,950 solder joints. So I would sit here 2 hours a few days ago and then solder 72 of the triangles.
I'm gonna get close to you. I'm not gonna get up to as much as you've done, but I have a clock kit that has 630 red 0603 LEDs. So I am hand soldering them, by the way. No hot air, no paste.
That's pain.
Yeah, I'm doing it
Because
live, so it's not so bad because I'm just hanging out with the chat while I'm doing it. But yeah, it's a lot of work.
yeah, for our PCBs, we actually panelized 15 PCBs on a single panel. So you have 5 triangles per panel. And then I would just panelize all of them. And I also bought a heater, these heat plates to solder it. It's the one Johnny Bergdahl recommended to me.
Oh yeah,
I think we all know him.
yeah. Of course, he's in all the live streams.
Yes, he's also a mod in all live streams.
Yeah, he is. I gave him mod in mine. I forgot for what reason, but I gave him mod in mine too.
He just has mod rights on every single channel. But yeah, he also helped with the project a lot. And I also did a few streams on Twitch working on this project. But yeah, I still have to do 2,100 solder joints for the 150 plus connectors I need to still solder. So that will be fun as well.
You should crowdsource it. Get some people and start a big an assembly line.
Yeah, I have a Weller soldering station, and I just set it to 380 degrees, and it just solders through all of it pretty easy.
Yeah, for sure.
Put on the biggest tip I could find, and yeah, I can
Just heat up the entire board.
Yes, it works.
You said you had a funny story about the JLC, was it?
Yeah, the funny story, it's for the secret Christmas project.
Okay, so you might as well start with the secret Christmas project then.
Yeah. The secret Christmas project is a few years back when I was still living at my parents' house. Remember those days? I just bought some APA individual controllable LEDs. They are much like the WS ones, but it's a different package. Those are through hole and 5mm LEDs. I think probably you know them.
Maybe. Do they have are they dumb LEDs or do they have micro inside?
They have micro. Those are the APA 106 F5.
Yeah, I don't think I've ever worked with them, but I think I know what you're talking about.
They are pretty much the same as the WS ones, but just a different form factor and a little bit different protocol, I guess.
And they're in like they're like in a plastic thing with epoxy out at the backside or whatever.
They are the normal LED type housing.
Oh, then yeah, no, I haven't. I don't actually know about those then.
They look like a normal LED, 5mm diameter, and they have also the microcontroller in it, so you can individually control them. So what I did was I made a digital Christmas tree, I would say, I guess. I took some wire, like thick, I don't know, 1mm thick wire, and made circles out of it using a water bottle, actually, a glass water bottle, to get them perfectly round. Because the top of the water bottle has this conical shape.
Okay.
And you can roll the metal around it to get a perfect circle. So whenever you want to get a perfect circle of metal, you just solder the ends of the wire together and roll it over the top of the bottle.
And this is a solid core wire, right? You're not talking about stranded?
Yes, it's like for woodworking and such, not for electronics.
Okay. Gotcha.
It's like, I don't know what it's called. You can get it at the Home Depot or something, probably.
So is it like brass then, or maybe some sort of like piano wire, like steel?
Yeah, I think it's steel.
Yeah. So it's probably piano wire. I think you can get them
But
in hobby shops and everything.
it's not easily bendable. It's very strong.
Yeah. So yeah, I think that's what it is. But if you're saying 1 millimeter square, that's about 18 American wire gauge, which would be a pretty substantial piece of wire.
Yeah, I think it's or even half than that. But it's pretty strong, and it's pretty hard to work with, and it's also hard to solder because solder does not like to stick to it. But what I did was I made a big ring or two big rings, one a little bit smaller than the other, and then two small rings. And then I took those LEDs and soldered them onto the rings. 6 ones for the bottom ring and 3 for the top ring. So what I did was I used, for example, the inner rings to pass through the negative connection to the power source, and the outer ring to pass through the 5 volts for the LEDs. So I had these rings soldered on the LEDs with the power connections, and then I just bent the legs of the data signals of the LEDs and then connected them also together. Then I took 4 strands of wire, and those were going to be the stem. So I probably know where this is going. It's going to be the Christmas tree stem. And then I had 2 wires which connected to the diagonal strands of the stem wires and go out to the inner ring and to the outer ring. So that's just to pass through the power. So I have a base plate, which is just a PCB with 4 stems, and then diagonal stems are connected to each other. So one diagonal pair is VCC and the other one is ground. And then I just had an Arduino Pro Micro or Pro Mini and connected it to that. And then I also soldered one LED on to the tip. So now I have a Christmas tree, and then I programmed everything. So I made some animations, I added a button. So I programmed it that way that when pressing the button, you could change the animation. And I thought of 10 animations, for example. And the 11th mode was that it just cycles through all the animations. Then what you could also change was the speed of animation and the brightness, all with a single button. So a single short press was changing the animation. A double press was changing the speed, I guess, and a long press was changing the brightness. So that's how you can get a lot of user interface out of a single button.
Yeah, I mean, and we see it on cheap Chinese products all the time. But
Yeah.
you, it was probably to challenge yourself, but for them, it was to save, the cent on the extra button.
So I made this thing, and I really liked it, and I also made some for my family for Christmas. And I always wanted to make a better version of it, which is easier to assemble and fun to build, I guess. So I sat down and made a PCB out of it. So it's a kit you can solder yourself. It consists of 2 rings where you can solder on these LEDs. We made them a little bit larger, the rings, than the original version, and also increased the LED count to make it more twinkly, I guess. So now we have 8 LEDs on the bottom ring and 4 on the top ring, and then 1 for the tip. And you have a base plate, and as a microcontroller this time we are using an ESP8266, the D1 Mini version. So you will have a Wi-Fi enabled LED Christmas tree. And yeah, it also has the button, so you can switch the mode, for example, but we want to make it as a kit and probably sell it on Tindy. I hope to get it up there in time, because that's where now JLC PCB comes in.
Here it goes.
I ordered the PCBs, and initially I wanted to do castellated holes for the The stem has PCBs that slide into the stem, which hook up to the rings.
Okay.
And I wanted to have, for the connection for the rings, I wanted to have castellated holes on the branch. Let's call it branch. Because the PCB are flat on top of each other. So you have this 1.6 millimeter gap that you need to solder in order to make a solder connection.
Makes sense.
Yeah, and that's why I wanted to have castellated holes on there. But it turns out adding castellated holes increases the price of the PCB to almost $1 per PCB for the branches, which are
Yikes.
the smallest PCBs of the whole thing. So PCB then told me during the ordering process, because I didn't. I saw on their site that you could do castellated holes without paying for them, but you would have some optical defects and such. So I just ordered it, and then they came back and said, no, if you want to do the free castellation thing, you need to change the hole size and everything. So I just said, yeah, then remove it. So no castellated holes for now.
So you're
But
just
that,
gonna butt the two
yeah,
PCBs together and just solder big
yeah,
blob?
you have to use a lot of solder then instead. That also shaved off a few days from ordering. So because I had to answer them and everything, so they could get back to production. So that took 2 days already. So last week they sent me an email. Oh, we scratched your PCBs during manufacturing. We need to redo them. So it will add 5 more days.
Oh no.
So today, actually, they were able to send and package them, but they would have been sent to me 1 week earlier.
So let that be a lesson. If you're trying to make a Christmas PCB, you have to design them in June.
Yeah, probably. We were a little bit too late and probably too optimistic. We started last month working on this.
Yeah, I'm always too late. I almost never make topical videos because I can't do it. Always too late. Or, I'll get 80% of the way through it and realize I'm missing a critical piece that is like a 60-day lead time from AliExpress. In which case it just goes, I just delete the whole video. Screw it.
Yeah, I also have a lot of video material of some things that just didn't turn out the way I liked them.
Yeah,
And
I mean, in my case, I don't have very many of those because my whole channel is kind of a low standard. But I can see how somebody that actually makes good videos would mind. Yep.
yeah, I also have some other projects I've been working on and then lost interest and want to get back to them. So actually wanted to make this Christmas tree for like over 3 years now, the PCB of it. But now was the time I got around doing it.
Well, at least you'll probably be good to go by next Christmas, and then maybe
Yes.
we won't be inside of a global shipping shortage.
Yeah, I actually ordered enough pieces. So I ordered 50 PCBs, so for making 50 trees. And I also ordered 60 ESP D1 minis, which I already have by my side. But
Nice.
that was an interesting bag.
I love the audio sound of the PCBs or the D1s in, I guess, a plastic bin, maybe.
It's a plastic bag with the anti-static bags inside.
Oh yeah, this sound is awesome. That you can make an ASMR video for that.
Probably.
Listen, our time actually flew by, and I usually have a question that I ask every one of my guests. Do you mind if I shoot that question to you?
Yeah.
So, I know that you're working on some important stuff in your day job, but the question goes: if you got, let's say, a government grant that would give you, pretty much unlimited money to start the business of your dreams, it wouldn't have to be profitable, but it does have to provide either a product or a service. What kind of business would you start?
That's a pretty good question. I do have other projects I'm working on, because that's obviously not the only one. And I would probably use it for the other project I'm working on currently, which is a smart beehive of some sorts.
Okay. Well, you
So
can't just leave that there. You'll have to explain to us
yeah,
what the project is all about.
yeah. Some people on the Discord already know about it, but the project goes this way: that we wanted to make a kind of sensor board, which is waterproof and solar powered, and which connects over cellular web network with our server.
Okay.
And you hook up a weighting scale to your beehive and then connect it to our sensor board, and also get a temperature sensor or humidity sensor and put it into the beehive. And we then want to gather all the data of the beehive, send it over cellular to our server, and then display it in an app for the beekeeper, and also determine the wealth of the bees, and alert the beekeeper when something is up.
Yeah, because bees are kind of picky, it turns out. If the temperature goes up a little bit too high or down a little bit too low, they'll swarm. They'll go looking for somewhere else, I think.
Fun thing about this project is that we started with it at the end of last year, and in the first 3 months, I developed a web application which also runs on Android and iOS using Flutter, which is my latest and greatest tool for making apps. I developed a backend server using Node.js, and I developed a PCB and client software using the ESP32, or no, yeah, ESP32, and it works pretty well. You can configure the connected sensors from within the web UI, which then gets sent to the web server, and the ESP connects to the web server over a cellular network every 5 minutes, and then gets its configuration from there, and also sends up telemetry data like the temperature sensors and everything, and the data then gets stored in a MySQL database on the backend. And what I also implemented was over-the-air software updates for the ESP. So the server also has a binary of the latest software, and whenever the ESP has an older software, you can then tell, currently only from within the database, you can put in a command in the database, because that's the way I programmed it, and it will then tell the ESP to download the new software binary from the backend server and install it on the ESP via cellular network.
So I just partnered up recently with a wizard myself, and the person says that if all goes to plan, we will also have our ESP updating itself over the air. So to me, I just think it's just magic at this point. So
It's
I
very
mean,
cool.
yeah, it is that you can actually do that. Like for me, I basically never show the actual programming of the microcontroller because my PC and my workbench where I film videos are like separated by 6 feet, and I've never had a 6-foot USB cable that's worked for more than a month. So to me, I just I just plug it in and then bring it to the workbench. But the thought of me being able to program my ESP without getting off my chair is just, there's just something delightful about
It's
that.
very cool. One fun thing, I also wrote a software to set up the ESP inside. So I made this PCB. We can currently connect up to 10 individual sensors to the ESP. It doesn't matter which one you connect to which port, because that's all done in software. You can just tell, yeah, this sensor is connected to that port, and then it will try to read the data from it. But I actually made a program which we can put on the ESP to initialize all the configuration needed. So you put the program on, connect to the ESP via serial, and then it will go through all the steps needed to set up the PCB. So it will first ask you for the PIN number for the SIM card. So you type that in, and then it will ask you if it should get the access token needed for communication with the web server. And then you can tell it to do that. And next, it will ask you if you want to install the software binary. So then you can select download and install the software binary through cellular network, or you can tell it to use Wi-Fi. Then once you selected Wi-Fi, it will scan all available Wi-Fi networks and list them with the signal strength. And then you can type in the number corresponding to which Wi-Fi network you want. Then it will ask you for the Wi-Fi password if needed. And if that's done, it will download the software binary from our web server and install it on the PCB, and then start as a B-box or whatever.
See? Wizardry. When you break it down into those steps, it's just complete wizardry. And I can't wait to get to a point where I can write software that actually does something useful.
Yeah, there are so many opportunities and what things you can do only with software.
Yep.
I mean, hardware is a whole nother level, like implementing software in a hardware level. But that's a lot more complex.
Yeah, super. That actually, yeah. Either way, it's making cool stuff sometimes is very complicated.
Yeah, also some other projects I've been working on was my parents have some chickens. They got them pretty recently. And I managed to talk them into doing a live stream with the chickens. So we got 3 cameras, put them up in the chicken coop, and now they are streaming every day on Twitch with the chicken coop. One thing I wanted to do was to naturally add a web-controlled chicken feeder, so you can feed the chickens during the live stream.
Nice. And I think for chickens, you need to shut the coop door at night or something, right?
Yes.
So, I mean, that's an easy task for someone like me to get started with. But to feed the chickens on a live stream, that's a little bit more complex.
I also made an automated chicken door, by the way.
There we go.
So for the chicken door, I actually used some spare parts from work. From the heliostats, which are the mirrors concentrating the solar power. So they are called heliostat. And from one of the broken heliostats, I took some of the motor drives, which are these linear actuators, and a control board. I then reverse engineered the control board through an ESP8266. It connects to the internet, gets the current time, calculates the sunset and sunrise times for each day, and then opens the door 20 minutes before sunrise and 20 minutes after sunset.
Nice. I thought you were going to say you were going to reflect light and try to hard boil an egg while it was still in the nesting box.
Yeah, it would be fun too.
Okay,
but yeah,
I've got a terrible joke, and then I think we've got to wrap it up before people start losing their minds. So here's my terrible joke. Why do chicken coops only have 2 doors?
I have no idea.
Because or else they would be chicken sedans.
I don't get it. I'm sorry.
In the automotive world, a coupe has 2 doors and a sedan has 4 doors. So we call a 4-door car a sedan,
mm-hmm.
and then you call a 2-door car a coupe.
All right.
Yeah,
I never knew that.
Yeah, it's fine. It's probably because it's not your first language, or it's probably because it's not a very good joke.
Either way.
Yeah. Do you have any closing thoughts?
Closing thoughts. I'm really bad at that.
That's fine. So how about telling people then where they should go to find you?
Find me. Easiest way is on YouTube.
Okay. We'll put the link in the description.
I actually have two YouTube channels, a German one and an English one. I try to make every video in German and in English.
Okay.
Because
Bit
that's
Looney
a
once said that learning German is the most useless thing you can do because all the Germans speak perfect English.
yes, that's right.
Okay,
Maybe
so
I
I'll
will
put
stop the German channel, but for now I will keep it.
yeah, either way, I will put the links in the description. And I guess also, do you have a Patreon people should go check out?
I don't have a Patreon, but I have the GitHub sponsors.
There we go. Okay, we'll put that in the description as well. And I would recommend the listeners to go sponsor a wizard because wizardry is not easy.
Yeah. Currently, it's another side project, but for the Flutter apps, I'm currently working on an integration for 0MQ sockets into Dart, which is already up on the pub dev. Probably you don't know what I'm talking about, but
I have no clue. I
but
have
that's
no clue, but I'm glad there are people who do know.
yeah.
Well, it sounds good. Thank you so much for taking your time and coming onto the podcast. I'm sorry I had to start the podcast late today, and that's another story for another day.
That's fine. But the podcast really went by quick, and
Yeah, you're telling me. I still don't even know how you're controlling those LEDs. So
yeah, no one knows.
wizardry.
No one knows except the ESP.
There we go. Okay, everyone. Thank you for listening, and I hope you're going to go check out Moritz's channels in the description. And if you've got a couple extra bucks laying around, go check out the GitHub sponsorship. Thanks,
Yeah,
everyone, for listening.
thank you for having me.